Okay, lesson 5, unit 6. We've already talked about the factor flow chart, where the first way to factor you always look for is a GCF. Always look for it. And then difference of two perfect squares. And then the third one where your trinomials, when your a equals 1 or your a is greater than 1 and use your arcing. We are going to talk about today factor by grouping, which I'm hoping is going to be rather familiar because we use grouping with the arcing. So hopefully you pick up on it pretty quick. And when you see the criteria, that's usually the method you're going to use. So what we have here in the first exercise is we want to factor a binomial common factor. So that just means you're going to take out a binomial term, which is what we do in arcing when we group them together. So when you look at letter A, you can see here's the first term, here's the second term. So what's in common? The 2x plus 1. So you take out a 2x plus 1, and you're left with x plus 7. Same thing in letter B, first term, second term, we're going to take out an x minus 2. So take out an x minus 2, you're left with a 5x minus 4. And then in the next two, a little more complicated because you have two sets of binomials, but you still take out what's in common. So we take out an x minus 7, and then you're left with an x plus 5 plus x plus 1. So this is where it gets slightly confusing because now you would have to combine those and make this a 2x plus 6. And then that would be your second binomial. So if you're able to combine once you factor, then you want to make sure that you do that. So in the last one, letter D, the x plus 4 is in common, x plus 4, and then 2x plus 8 minus x minus 2. So this is a little more difficult because you have the subtraction. You have to distribute that negative through, make that a minus x and a plus 2, so then it becomes x plus 10 is your second binomial. Now, in exercise 2, they are just making sure that you end up with the same value. So once you take out the x plus 3, you're left with an x minus 4 plus 5, which is x plus 3, x plus 1. Okay, those are your binomials. And then all they're doing is checking when x is 2. So you would put 2 in with the such that x equals 2. Some people lost some points on the quiz because they still don't know how to substitute in with such that. Easy credit to receive. So especially when they give you a negative, you don't want to make an error with that. So when you plug the 2 in, you get an output value of 15. Same thing here, x equals 2, and you get the output value of 15. Just a way that you can always check when you're even way back up here. And if you want to make sure that your factor is the exact same as the given one. So you can put a value in any value, 2, 4, 6, anything you want to use at all. Okay? I'm going right over to exercise 4. All right, so I'm skipping that exercise. We'll talk about it in class with the properties. Here's your factor by grouping. So the criteria is it has to have 4 terms. So you have 4 terms, and of course you always look for a GCF. The highest term is usually x cubed. If it's an x to the 4th, that means the last term will usually have an x. You could factor out an x first. So when you're factoring by grouping, you group the first 2 terms, group the second 2 terms, just like we did in arcing. Then take out what's in common. Okay, so we have x squared, and then we have 3x plus 2 left. So then what you want to happen is you want this to be a 3x plus 2. Okay, now in grouping, if it does work, then you could factor by grouping. But if it doesn't work, then you cannot factor by grouping. So when we did arcing, we had to force it to be the exact same binomial. But when you're grouping, it doesn't have to be. Okay, so you got to be very careful with that. So what we can take out is a negative 9. Okay, to give me back to that negative 27x minus 18. So then your 3x plus 2, and then x squared minus 9. Now you have to be very careful because it says factor completely. So we have to be able to also notice now that this x squared minus 9 is a difference of two squares. So it's x plus 3, x minus 3, and then don't forget the 3x plus 2. So this is factored completely. Okay, so you got to go as far as you can. In the next one, you can't take out a GCF. So we group the first two, group the second two. I'm going to take out a 9x squared. I'm left with a 2x plus 1. And I want a 2x plus 1 over here. So I factor out a negative 1. So you have 9x squared minus 1. And then the 2x plus 1, which was in common. And this 9x squared minus 1, again, difference of two squares, 3x plus 1, 3x minus 1, and then 2x plus 1. All right, and that's factored completely. They don't always have a difference of two squares, but that's going to be the most common one that you will see when you are using grouping. Now, in the next one, we have an x to the fifth. So you want to see if you could take out any amount of x. So you look at every single term, but there's not an x in every single term, so you can't take it out. So you still have four terms, so you try grouping. Okay, we could take out an x cubed. I'm left with an x squared plus 4. Okay, so you want to see if you get an x squared plus 4 left in the second two, and what you could take out is a positive 2. So you take out the positive 2, and you have your x squared plus 4, and then x cubed plus 2, and that's how it factors. Now, you might look at this x squared plus 4 and say, oh, it can be x plus 2, x plus 2. No, it does not factor like that. Okay, if you were to do that, you would have middle terms of 2x and 2x, which give you a 4x. So you got to be very careful. All right, now the next one, if you look at your terms, okay, here we can finally take out a GCF. So we take out a 5, you're left with an x cubed plus 2x squared plus 4x plus 8. Okay, so always check for that GCF. And then you group the first two, group the second two. I could take out an x squared. I'm left with an x plus 2. And I want to make this an x plus 2, hopefully. And I can take out a 4. So then I have the x plus 2's, the x squared plus 4, which cannot break down any further. And then don't forget the 5. Okay, because we're just factoring. We have to make sure that we don't lose that GCF. When we get into solving, it's going to be a little different story. Okay, but for now, if you're just factoring, you have to make sure that you have it. Okay. Now, the next one, it could be a little more generic by not having any numbers. Okay, so this one, you might be like, what is going on here? So they're testing a rule. So we want to try the same thing. You group the first two, you group the second two. Okay, there's nothing in common in the first two terms. There is something in the second, but there's nothing in common. So what you might have to do is you might have to rewrite the expression. So we have an x squared, and I'm going to take this minus ax and put it first. Minus ax plus ab minus bx. So I just rearranged the order. Now I'm going to see if I can factor out. Okay, so I'm going to factor out an x. I'm left with an x minus a. And then I want to try to make this an x minus a. So if you take out, we're going to take out the b, but if I take out a negative b, what you're left with is a negative a plus x. Okay, so that's very confusing. I might have to pause it to see what I did there. So I'm taking out a negative b because I want an x minus a. So then you could switch the order of these two. So that would be, and I'll come over here because this is really doing a and b together. So we have an x, x minus a, minus b, and then the x minus a again. Okay, and then you could factor out the x minus a, and then the x minus b. Okay, and that's how it factors. All right, so be careful of that. That's more like a rule. They might have that as a part 2 question on the exam to try to trick you and see if you're able to use the rule with the variables. All right, and what do we have for the last one here? Yeah, it's not uncommon to see this either. Consider the expression why there is an error made in factoring and why is it incorrect. Well, what happens here when you factor, remember, you want these values to be the same. So if I was to factor out the 2x and get an x plus 5, I want that to be an x plus 5 as well. If it's not, then we can't factor it. Okay? And then if we want to find zeros, we will go over ways to find the zeros later on in this unit and then into upcoming units as well. So that's about all I have for this one for grouping. Hopefully it's not too bad, okay, because it is like arcing. So we'll work on some problems tomorrow, and we'll continue with the complete factoring from lesson 4. We'll see you in class.